Hello everyone, in this video I'm going to talk about IPv4 address, and I will talk mainly about classful IPv4 addressing. The first thing I will start with is a byte. A byte is made of 8 bits, and the values that we can have in a byte start from 0 up to 255. So here we talk about the IPv4 address format. It's 4 bytes. IPv4 address is made of 4 bytes: byte 0, byte 1, byte 2, byte 3. And we have to know that the value in each byte is represented in the decimal system, and these 4 bytes are written as dotted quad decimal notation, using the dotted quad decimal notation, where bytes separate with a dot. Now, originally the IPv4 addressing space has been divided into 5 classes. We have class A, class B, class C, class D, and class E. IPv4 supports different communication types. So IPv4 addressing, it can be used for unicast communication, which supports the one-to-one communication model. Also, they can be used for multicasts, which implements the one-to-many communication model, or we have a broadcast communication, which implements one-to-all communication model. So we have 3 different types with IPv4. So let's start with the first one, unicast IPv4 address, or one-to-one communication model. This type of communication is implemented using the first 3 classes, class A, class B, and class C IPv4 address, which means that an IPv4 address in any one of these 3 classes can establish one-to-one communication with another IP address in any one of these 3 classes as well. Of course, here we mean a host assigned an IP address in any one of these 3 classes. That host can establish one-to-one communication with another host which has an IP address in any one of these 3 classes. For example, here we have clients and servers. So the clients talk to the server. Each client needs to establish connection or session, separate session with the server. It should have its own session or connection. So for example, client 1 requires hundreds kilobits per second of bandwidth in its connection to communicate with the server. Client 200 kilobits per second, client 300 kilobits per second. So on the server side, the server should be able to deal with 300 kilobits per second. Now imagine we have large number of clients, so you have to multiply this bandwidth by that number of clients. So here is just the number. We have to worry or care about the number of connections or number of clients which are going to connect to the server. This is implemented in one-to-one communication model. Now we have the multicast IPv4 address, or one-to-many model. The multicast IP address is represented in class D, and here we have a sender. Sender is going to send, let's say, video content or audio content to a destination multicast IPv4 address. You see, single stream of information is delivered with 100 kilobits per second only. This stream of information is going to be received by all those hosts which are interested to receive that information and which are going to act as receivers. So in one side we have sender, and the other side we have receivers. But of course, not all hosts are interested to receive the content. So we have a certain group like host 2, host 3, host 6 who are interested, but host 1, host 4, and host 5 are not going to receive it because they are not interested. So that's why this model implements one-to-many. So many computers, but not all. The receivers, they can be in the same LAN or they can be in different LAN. It doesn't matter. So they can be same network where the server is connected, or they can be in different networks. For example, host 2 is in one network, host 3 is in a different network, and the same thing with host 6. We have a broadcast IPv4 address, or which implements one-to-all model. Here we have one computer acting as a source, sending information to everybody. Destination 1, destination 2, destination 3, destination 4, and 5. So all computers are going to receive whatever is being broadcast by the source computer. So this is the broadcast IP address. Now, when we talk about the IPv4 address, we have to mention one thing very important, is that IPv4 or an IP address in general is made of two components or two parts, the network address and host address. So we should be able to extract network address from IP address. Also, we should be able to extract the host address from the IP address as well. But if we deal with the network address alone, it cannot be considered as valid IP address. So you cannot assign network address to a computer. If you deal with host address alone also, you cannot assign it to a computer or to a device. A device needs an IP address, and IP address is simply a combination of these two parameters. Now let's start with the class A. How to identify class A IP address is very simple. Just look at the leftmost byte. So this byte here, which is in red color, values between 0 and 127. So if you find an IP address with the leftmost byte having values between 0 and 127, automatically this is a class A IP address. Once we identify the class that it's class A, we know that class A, the leftmost byte contains the network address, and the remaining 3 bytes are going to hold the host address. So this is very important. However, if we go back to the network address, we're going to see that the value 127 is reserved for a loopback address. So you cannot create class A IP address which starts with 127 and assign it to a computer, because 127 is reserved for loopback address. Also, value 0 here is reserved for something else. So in the case of a machine acting as a server, and that machine has many network interface cards, so if you use this IP address 0.0.0.0, it means here you are referring to all IP addresses assigned to the various network interface cards for this multi-homed server. Also, 0.0.0.0 is used to designate an invalid, unknown, or non-applicable target. That's why now we're going to remove 0 and 127, so this interval will shrink to 1 to value between 1 and 126. So now, if you want to create class A IP address and assign it to a computer, starting value should be between 1 and 127. Still, that this byte here in red color, surrounded by red, is going to contain the network address, whereas the green colored bytes are going to contain the host address. So as an example of network address, we have 10.0.0.0. What you notice here in red color, this is network address. In green color, this is the host address. But what you notice is that the host address is 0. All bits in host address are set to 0. So in this situation here, we are talking about network address, just network address. There is no host address involved, because the host address field is set to 0. Broadcast address is different. Now, set all the bits in host address field to 1. So 3 bytes here are set to 1. So 8 bits set to 1. So the decimal value will be 255. Same thing here, set all the 8 bits to 1. Convert back to decimal, you will find 255. And same thing with this byte also. So the broadcast address will be 10.255.255.255. We have also another type of broadcast address, which is limited broadcast address, where all the bits of destination IP address are set to 1. So you come up with something like this: 255.255.255.255. This is a limited broadcast address. Now, if you send a packet to this limited broadcast address, the packet will stay in the network where it originates. It cannot be routed. It will stay, it's restricted, confined only to its native network. Now, the range for this network address, and it's the range of IP addresses that belong to this network address, starts from 10.0.0.1 up to 10.255 to 255.254. Here I'm showing the 2 binary values, and I'm using the logical AND between these 2 binary values to generate this result. 1 and 1, 1, 0 and 1, 0, 1 and 1, 1, 0 and 1, 0, 1 and 1, 1, 0 and 1, 0, 1 and 1, 1. So take class A IP address. You see 10 here is within this interval, 1 to 127. So this is 126, sorry. So this is class A IP address. And in class A, we know that the red colored here is The red colored part is the network address, and the green colored part is the host address field. And this is the default subnet mask for class A. So we said default because it can change, but the default value of subnet mask is 255.0.0.0. Now you convert the IP address to binary, you convert the subnet mask to binary, logically AND between the two. The result converted back to decimal, and this will be your result, 10.0.0.0. So what is your conclusion? You see here all the bytes, all the bits in the host address field are equal to 0, so the result will simply be network address. So whenever you take an IP address, logically end it with a subnet mask, it will result into a network address. Now, how many bits do we have in a host address field? We have 24 bits, because 3 bytes, each byte 8 bits, 3 times 8, 24, so we can have 2 to the power 24 different combinations. But we have 2 combinations which cannot be valid host addresses. One combination where you have all 0, that combination will be used to identify the to write a network address, and the second combination where all bits are equal to 1, this combination is reserved to broadcast address. So you can compute now to the power 24 minus 2 is equal to 16,777,214 hosts. So this is a number of hosts that can be that can exist in a class A IP address. Same story with class B. How you recognize that IP address, an IP address belongs to a class B? Just look at the leftmost byte. The value here is between 128 to 191. Automatically this is a class B IP address. Once you identify this class B, then you know that the characteristic of class B is that the 2 leftmost bytes contain the network address, and the remaining 2 bytes here in green contain the host address. As an example of class B network address, we use 172.16.00. You see, the host field here is zeroed, so here we're talking about network address. But what about if I set all the bits in the host address field to 1, so it becomes a broadcast address? Limited broadcast is the same as the one with the in the class A, so all bits of destination IP address are set to 1. And remember, any packet sent to this destination IP address will not leave the network, its native network. And this is the IPv4 range. This is a range of IP address that belong to network 172.16. It will start from 172.16.0.1 until up to 172.16.255.254. Same thing here. I'm using 2 binary values, logically ending between them, and generate this result. You can do similar thing with IP address. Take an IP address, let's say this is a class B IP address, logically end it with its default subnet mask, which is 255.255.0.0, and this will be the result. The result is 172.16.0.0, which is in fact the network address. So and how many hosts can we have in a class B network? Just count number of bits in the host address field. How many bits we have? We have 16 bits, because 2 bytes, each byte 8 bits, 2 times 8, 16, so to the power 16 minus the 2 combinations where you have all zeros and all ones in the host address field. These 2 combinations are reserved for network address and broadcast address respectively. Then you find this value here, 65,534 hosts. This is the number of devices that can be hosted in a class B network. Now class C IP address, very simple also. Look at the leftmost byte. Leftmost byte value should be between 192 and 223. Whenever you find an IP address with this range, with value in this range, automatically this is a class C. Now once you know it's class C, you know something else is that these 3 bytes, the 3 leftmost bytes contain the network address, and this byte only in green color contain the host address. Now this is an example of network address 192.168.0.0. You see 0 here in the host address field is zeroed, so here we're talking about network address. But if we set all the bits to 1 here, we are generating broadcast address for this network. Now limited broadcast is the same as before, and this is the range of this of IP address that belong to this network address 192.168.0.1 up to 192.168.0.254. Here also again I'm showing the binary values to logically AND to generate this result. We can apply similar thing to our class C IP address with its default subnet mask 255.255.255.0. So logically ending between IP address and subnet mask, it will generate the network address. How many bits are in the host address field? 8 bits, because the host address field now is only 1 byte, so we have 8 bits in the host address field, but still two combinations are not valid host addresses. You cannot use them to assign IP address to computer. The combination will have all zeros, which is reserved for network address, and combination with all ones, which is reserved for broadcast. So we compute to the power 8 minus 2, we generate this value here. This is the result, 254 hosts, which means that each class C network can host up to 254 different devices, computers, servers, printers, etc. So now to wrap up, what is the purpose of subnet mask? Subnet mask is just a parameter which comes with the IP address, and the purpose of subnet mask is to help identify which portion of the IP address is the network address and which portion is the host address. So the subnet mask will help you identify or extract the network address from any IP address as well as its host address. So if you are provided with an IP address, either you have to be given its related subnet mask. Subnet mask here is a must, unless you are indicated that the default that it comes with the default subnet mask. For example, I give you a class C IP address with a default subnet mask. Default subnet mask of class C, it is 255.255.255.0. The default subnet mask for class B is 255.255.0.0, and the default subnet mask for class A is 255.0.0.0. Now, other than that, an IP address with an unspecified subnet mask, it will not be acceptable, and you cannot work with it. Now let's go to class D. In class D, it's a different story. Look at the leftmost byte. Value should be between 224 and 239. So whenever you find or you see an IP address whose leftmost byte value is within this range, so automatically it's class D. Class D, which is used in the multicast domain or one-to-many communication type. So in class D, we don't have a subnet mask. Since we don't have a subnet mask, there is no such a thing as a network address or broadcast address or limited address. So there is no such thing as network address and host address. There is no subnet mask. So it's just combination of bits. The most important thing is that the leftmost byte value should start within this interval. We have a class E. Class E was created with the value in this leftmost byte between 240 and 247. So whenever you are dealing with an IP address whose values in the leftmost byte are within this interval, so it is class E. Again, it does not have a subnet mask, so there is no concept of network address, broadcast, limited, and so on. So we don't have a network address and host address, just combination of bits. The most important thing, look at the leftmost byte value. It should be within this value to identify the fact that this is a class E IP address. And finally, we have the undefined range, the free range, which is from 248 to 255. Again, there is no subnet mask, so there is no such thing as network address and host address. Now, let's go through this simple exercise. For example, let's consider that all these IP addresses are classful IP address. So the first thing we need to do is identify the class. For example, this is an IP address, as you see here. What is the class of this IP address? What is its default subnet mask? And what is its network address? So let's start with this IP address, 23.1.2.5. So if you look at the range of values in the leftmost byte, you will understand that 23 is simply a class A IP address. Okay, now we know what is the subnet mask. Let's say the default subnet mask is 255.0.0. Okay, this is .0.0.0, and the network address is 23.0.0.0. So you have to zero all the bits in the host address field. The second IP address, if you look at 166, you understand is between the range is between 128 and 191. So this is class B. Okay. What is a subnet mask? Default subnet mask for class B? It is 255.255.0.0, and in this case the network address is simply 166.25.0.0, because we have to be formal, so we have to represent what happens to the remaining bits by zeroing them if we want to talk about network address. Now the third IP address here is simply, you see 220 is between 192 and 223. This is a class C. And the default subnet mask for class C is 255.255.255.0, and the network address is 220.2.5, of course, .0, because we have to be formal again. Remaining here 230. What do you think? 230 is class, so this value is between 224 and 239, so automatically this is class D. Do we have subnet mask for class D? No. Is there network address? No. This one's 249. 249, this is undefined range, which starts from 248 to 255. So again, it does not have a class. Okay, there is no class, and there is no subnet mask, and there is no network address, so it's not applicable to this type of addresses. So the most important thing now, to wrap up with this, we have to understand one thing. You are given an IP address. Okay, you are given an IP address, and then you have to look at the leftmost byte. What is the value of leftmost byte? Based on that value, you can identify the class. Only on that value. You will never look at the subnet. Don't look at the subnet mask in order to say whether this is class A, class B, or class C. Always look at the value in the leftmost byte. I'm talking here about classful IP addresses, of course. So in a classful IP address situation, subnet mask will never be used to identify the class. Only the value of the leftmost byte, like in this situation here, which is used actually to identify the class of IP address. And this is very important. Now, if you look at, for example, class D, class E, or undefined range, of course, definitely they don't have subnet mask, and they don't have network address. So you can simply say that this information is not, or those parameters are not applicable to this type, these classes. Now, we have something very important here to mention. So whenever you are provided with an IP address, you have an IP address, unless said otherwise. For example, you should have also the default, the subnet mask. Okay, if we mention default subnet mask, we don't need to write 255.0.0.0 because we know what is the default for that particular class, or we can mention it also, there is no problem. Now this is one way of writing the information, IP address and subnet mask. However, this is the IP address with subnet mask. There is another notation that we use, which is called the classless interdomain routing, CIDR notation. In CIDR notation, what you will do, you will write the IP address like this, followed by slash, followed by number. What is this number 8? Number 8 is simply the number of bits set to 1 in the subnet mask. So if you look at the subnet mask here, you find you have 255. Convert back 255 to binary, you will find 8 bits. So 8 means that we have 8 bits set to 1 from the in the subnet mask, and we have always to count starting from left, so from left to right, and count this number of bits. So this is another way of writing. It's like shorthand notation. Let's look at the next IP address, 172.16.0.1. It's given the subnet mask. It's the default, of course. You could have omit to write the subnet mask if they mention the default subnet mask for class B, or it's okay, the subnet mask is mentioned here, is specified. So this is one way of writing, and we have another way, which consists of writing the IP address followed by slash followed by number. What is 16 here? 16 is simply the number of bits set 1 in the subnet mask. So here we have 8 bits, here 8 bits. 8 plus 8 is equal to 16. So you count 16. So always start counting from left to right. Here also it's the same thing. We have an IP address, we have a subnet mask. Okay, so you can write it like this, or you can use CIDR notation, which consists of specifying the IP address, same as the one that you see here, followed by slash and followed by number 24. So I guess now you know how I extracted or generated 24. Simply count number of bits in the subnet mask, set 1 in the subnet mask. So we have 8 bits here we have 8 bits, and here 8 bits. So 8 times 3 is equal to 24. So we have covered now the most important aspect of classful IP address. I will see you in the next video to talk about subnetting.